Welcome to this explainer. Today, we're doing something really cool. We're looking right under the hood of smart factory ecosystems. When we talk about automated manufacturing, we always hear about the MES, the Manufacturing Execution System, right? It's basically the brain of the whole operation. But hey, a brain is completely useless if it can't talk to the body. So how do all these separate, wildly different machines on the factory floor actually talk to that central brain? Well, we are going to decode that machine communication today and figure out the actual logic that makes a smart factory truly smart.
Okay, so here's our roadmap. We'll quickly hit communication basics, move into state versus event-driven systems, check out SCADA, dive into edge computing, and finally, look at how to future-proof your procurement so you don't make a massively expensive purchasing blunder.
All right, part 1, communication basics, the literal foundations of the factory.
Picture a typical factory floor for a second. You know those classic 3-color indicator lights on top of the machines? Red, yellow, green. Seems super simple, but how does the factory's brain, the MES, actually know which one of those lights is currently on? Is the system just staring at the machine all day, or does the machine sort of raise its hand and announce its status? The answer to that question fundamentally changes how efficiently your factory runs.
Which brings us to part 2, state versus event-driven communication, two totally different paradigms.
Let's look at the contrast here. On the one side, we have the state mode. This uses something called polling. The central system basically has to constantly ask a PLC, a programmable logic controller, hey, is this address on or off? Over and over again. It's incredibly resource-heavy and honestly pretty passive. But then on the flip side, we have the event mode. This is a push system. It's trigger-based. The machine actually takes the initiative and sends a signal outward, but only when something happens, like a process starting or ending. It's way more proactive and highly efficient.
To make this perfectly clear, think of polling like exhausting yourself by calling a friend every 5 minutes just to ask, are you home yet? How about now? Are you home? It takes a ton of effort and bandwidth. Event-driven communication, though, is like just getting a quick push notification on your phone the exact second they walk through the door. The host system doesn't have to waste time asking, it just efficiently waits for the update.
And this has a massive impact on the factory's brain, the MES. With event-driven systems, when a machine actively sends a process start signal, it can automatically bundle all that vital trace data right alongside it using protocols like SEX/GEM. It's seamless. State-based polling, on the other hand, oh man, it's a headache. Usually you have to build these crazy, fragile translation tables just to convert a PLC's basic 0 and 1 address states into something the MES understands. If an engineer changes a single address on the floor and forgets to update the table, the whole system breaks. Plus, operators often end up manually clicking on screens to track processes, which literally defeats the entire purpose of automation.
Moving on to part 3, SCADA, the eyes and hands of the operation.
Enter SCADA, or Supervisory Control and Data Acquisition. Think of this as the visual dashboard for the folks actually on the floor. It gives operators a human-machine interface, an HMI, so they can instantly see which machine lights are on or check out real-time trend charts. This is absolutely crucial for monitoring continuous factory systems like water, electricity, and gas. Instead of waiting for the big MES brain to process and translate everything, SCADA lets the local operator see alarms, monitor processes, and even run equipment directly from their screens, right in the moment.
All right, part 4, edge computing. Building decentralized reflexes.
Here's the thing. As your factory scales up from a few dozen machines to maybe hundreds or thousands, piping every single piece of data up to a central server or the cloud creates a massive, crippling bottleneck. It's just too much traffic. So you have to build reflexes into the factory by moving the computing power way closer to the actual data source. Instead of sending data miles away to a cloud server to be analyzed, you just slap an industrial PC right next to the machine. That's edge computing. It creates this decentralized, hierarchical structure where the immediate environment just handles its own data first.
And this approach is built on 4 essential pillars. First up, fast. Because the math is happening right next to the machine, reaction times are practically instant. Second, save. You aren't uploading every tiny raw data point to the cloud, which saves an absolute ton on network bandwidth and storage costs. Third, stable. If the external network drops, no problem. Your local edge devices keep the factory running. You don't have a complete shutdown. And fourth, smart. It lets you make timely, on-the-spot judgments, like simple optimizations or basic predictive maintenance, without waiting on instructions from the cloud. The cloud still handles big data and long-term trends, for sure, but the edge handles the immediate reflexes.
Finally, part 5, future-proofing procurement, smart purchasing.
There's an old saying, a good cook cannot cook without rice. Well, the harsh reality is that a smart factory is literally impossible if your underlying machines are dumb. You can't just magically integrate automation out of thin air if the raw networking and communication capabilities aren't actually built into the hardware from day one. Buying older, disconnected equipment will stop your smart factory dead in its tracks.
So how do we fix this? You've got to fundamentally change how you buy equipment. In a modern workflow, IT absolutely has to consult and co-sign on purchases before a single dime changes hands. You have to establish your communication specs up front, demanding protocols like OPC-UA, Modbus, or SexGem directly from the manufacturer. Look, adding a comms module during the initial purchase is super cheap, but trying to retrofit an old machine to talk to your network after it's already bolted to the floor, the cost is astronomically high. To wrap up this explainer, I want to leave you with something to think about. Take a really close look at your own operations, your own workflow, or the projects you're focused on right now. Ask yourself, where is the biggest bottleneck today that a decentralized, event-driven architecture or even localized edge computing could completely eliminate? Where is that spark of efficiency just waiting to be unlocked? Keep that in mind as you look toward building the systems of tomorrow. Thanks so much for joining me for this explainer.